Hi everybody. This first video is on linear equations and inequalities. Um, and so some of the objectives in this chapter, we're going to solve linear equations, which most of you will probably be familiar with. Those are the most basic types of equations that you've probably learned how to solve. We look at solving word problems with linear equations. Solve like formulas that you might see in your chemistry or physics classes or economics classes that involve linear equations. Those are sometimes called literal equations because they have lots of letters in them. We'll also look at solving linear inequalities in 1 and 2 variables. So something where you'll replace the equal sign with like a less than or greater than sign. We use the rectangular coordinate system, or sometimes called the Cartesian coordinate system, to graph equations, and then we'll talk about parallel and perpendicular lines. So in this first section, we're going to look at linear equations. And so the objectives in this section will to determine, first of all, whether a number is a solution to a given linear equation. And then we'll talk about procedures for solving linear equations. And again, you guys, most of you are probably pretty familiar with this already, so this is largely going to be review. So if I get going too fast on this, you can always, of course, stop the video and rewind it and watch it. And I don't think you guys will have too much trouble with this first chapter, but if you do, don't be afraid to contact me if you do have any questions. And then the last thing we'll determine is whether an equation basically has one solution, no solution, or infinitely many solutions, and we'll call those conditional equations, identities, or contradictions. So first of all, let's talk about what does it mean to solve an equation, right? So if you wanted to solve an equation, you basically want to find all the numbers that you can plug into the equation that makes both sides equal. So one way to solve any equation is to just guess, right? But that's not necessarily the best way to do it. So for example, if you look at this particular equation, it might be kind of hard to tell what number you would put in for x, or numbers you would put in for x to make both sides equal. And we're mainly going to deal with linear equations, first of all, which means we won't include things like x squared. You might already know how to deal with those. But so one thing that the book might have you do is determine if the following values satisfy the given equations, right? So if you're given this particular equation, do these numbers make the equation true? And so what you would do is just try these one at a time and see what works and what doesn't, right? So for example, you would just go ahead and take the -4 and try plugging that in for x and see if you get 0. So if I take 6 times -4 minus -4 squared, does that give me 0 is the question, right? So I'll get -24 minus 16, and there's no way that's going to be 0. So for example, -4 would not be a solution. Then you do the same thing with 3. So take the same equation, wherever you see an x, put in a 3. So I'll have 6 times 3 minus 3 squared. Is that 0, right? Well, that's not true, because that'll be 18 minus 9. That's not 0. And one of the answers that they give you should work. And again, it might be faster for you to just solve the equation, but in some cases it won't necessarily be obvious. So, if you see a solution that's going to work, and there could be more than one, I guess you can just write that down. But I typically won't have questions like that on the exam. But remember, that's one way to solve an equation, is to just try numbers until you find something that works. Now, in this case, you're given a finite number of things to try. In real life, right, I mean, there are lots of things you could maybe put in for x, like fractions or things with square roots. So, so it's a lot harder for some equations to just try numbers, because you could try numbers forever and still not find the answer. So what we'll want to look at is methods for solving equations. And again, we'll mainly concentrate on linear equations first, which would mean we wouldn't include things with x squared. But there might be some problems like that where they'll give you an equation and they'll just say, okay, try these numbers and see if any one of those numbers or some of those numbers are solutions. So just try those one at a time and see what you get. So like I said, mainly we're going to look at solving first-degree equations. These are sometimes called linear equations. And so I guess the reason why they're called linear equations is that if you were to set the this equal to y here, you get the equation of a straight line. They're sometimes called first degree equations also because the power on the x is a 1. But just because the power on the x is a 1 does not necessarily mean it's linear. In order for an equation to be linear, you have to be able to put it in this form. So you might have something where you have like a over x is equal to b. So the power on the x there is 1, but it's also not linear. So just because the equation is of first degree does not necessarily mean it's linear. Technically, it has to be of this form, where a and b are constants. So you'll basically have a number times x plus a number is equal to 0, and a and can't be 0 in this case. If it's a is 0, then it's not a linear equation. So an example of a linear equation would be something like 3x plus 5 is equal to 0, or something that you can simplify and put in that form. You might have equations that are more complicated to begin with, but if you simplify the equation, it should simplify it down into the form of a number times a variable. It doesn't have to be x plus another number is equal to 0. So you might remember when you're solving linear equations, or the most basic types of equations, one of the things you want to do basically is whatever you do to one side, as long as you do it to the other side, things will stay equal, right? So, and your book will kind of break these down into different properties, but they're really all the same thing, right? This property is basically saying if you add the same number to both sides of an equation, the equation will stay equal. That's called the addition property of equality. Subtraction also, if you subtract the same number, like let's say c from both sides, then the equation will stay equal. That's called the subtraction property of equality. If a is equal to b, if you multiply both sides by the same number, then both sides will stay equal again. That's called the multiplication property of equality. And if you have two things that are equal, if you divide both sides by the same thing, they will stay equal. That's called the division property of equality. But more generally, you might remember whatever you do to one side of the equation, whether it's adding, subtracting, multiplying, or dividing, you have to do the same thing to the other side. So here's the procedure for solving first degree or linear equations. So the first thing you want to do is simplify both sides of the equation. That might involve combining like terms or getting rid of parentheses. And then use the properties of equalities to get all the things with the variable, in other words, all the things with like x or something on one side of the equation, and all the things without x on the other side of the equation. Then you might have to simplify both sides again. So again, you might have to combine like terms. And typically with step 2, you really want to just add and subtract to both sides. And then once you've simplified both sides, then divide both sides by the number in front of the x, or the coefficient in front of the variable, and then always try to remember to check your answer. If you're sure you've done all the arithmetic correct for a linear equation, the answer that you get should be correct, but sometimes you might make silly mistakes, like you mean to add 2 to both sides and you accidentally subtract 2 or something. So although I'm not going to take points off for it at this point anyway, I would strongly encourage you to check your answer. So let's look at a simple example. So let's say, for example, I want to solve this equation, right? Ultimately, what you want to do is try to get the equation by, getting the variable alone, or isolating the variable on one side of the equation using the properties of equality. So let's say I give you the equation x minus 3 is equal to 11. So again, you want to simplify both sides if you can. Well, both sides are already simplified. You cannot combine the x and the negative 3 together. So since both sides are already simplified, move on to step 2, which would be to use the property of equality to get all the stuff with x on one side and all the stuff without x on the other side. So although there are several ways to do this, the easiest way to do this is just to add 3 to both sides of the equation. So then you'll get x is equal to 14. And then, again, you might want to just double check your answer to see if that's right. You'll notice in this case, we don't have to divide anything because the coefficient, or the number in front of the x, is 1. But again, you might want to check your answer just to be on the safe side. This one's pretty easy. I won't necessarily do that for all of these, but for this one's pretty easy. If you take 14 minus 3, it does give you 11. So that does check out. So let's maybe look at a slightly more complicated example. Again, going back to this procedure, I may not go back to this slide anymore, but essentially for all these problems, we're using the same 5-step procedure here. So let's say, for example, we wanted to solve this linear equation. So the first thing you want to do is simplify both sides. They're already simplified as much as you can. Then add 9 to both sides of the equation to get the term with the a by itself. And then lastly, divide both sides by 3 and you'll get a is equal to -5. And then if you have time on the exam, check your answer, right? Plug -5 in for a, and you will see that you do get -24 on both sides, so that does work out. Let's look again at a slightly more complicated example. So in this case, again, I want to combine like terms on each side. Well, again, I cannot combine these terms together. I cannot combine these terms together. So at least on each side, they're already simplified as much as you can. But remember, you want to try to simplify first, and then get all this stuff with a on one side and all the terms without an a on the other side. So what you could do, for example, is, and there are several ways you could do this, but one, you could maybe add 15 to both sides to get all the a's on the right-hand side, but we're just going to add 8 to both sides. So if I add 8 here, this will cancel out this 8, and if I add 8 to the 15, -15 plus 8 is -7. And then all I have to do is take the 2a and move that over to the other side. So if I subtract 2a from this side, subtract 2a from this side, I'll get a is equal to -7, and you'll notice I don't have to divide the number in front of the a by anything here like we did in the last example. So that should be the answer, but again, you might want to check it by just replacing the a with -7 here and the a with -7 here and working that out to make sure you get the same thing on both sides. And in this case, you do get -29 on both sides. So let's look at a slightly more complicated example. Now this one will involve parentheses. So in that first step, remember what you want to do is on each side you want to distribute over the parentheses and then combine like terms. So on this side you'd want to take the 3 and multiply it times the x to give you 3x. Take the -3 times the 2 to give you -6. Watch your plus or minus signs there. On the right hand side, the 4x and -x are like terms. Remember, terms are like if they have the same base and the same exponent. So it's like you've got 4x's minus an x, which would leave you with 3x's. And then just continue to combine like terms. So here I'd have -2x minus 3x, which would give me -5x. 12 minus 6 is 6. Here I'll have 4x minus x is 3x, which we've seen, and then 12. So again, I've simplified both sides. Now I want to try to get all the stuff with x alone on one side. And technically you don't have to do that. You can start moving stuff around from one side to the other. But to me it's always easier to simplify first and then move stuff around, because then you'll have all your x's sort of grouped together there. And again, it doesn't really matter what side you put the x's on. So let's go ahead and add 5x to both sides. So if I do that here, I'll be left with a 6. If I take 3x plus 5x, I'll get 8x. And then I'll have a 12. So if we're going to move all the x's to the right-hand side, we want to get the 12 over to the other side by subtracting 12 from both sides. So if I subtract 12 from this side and subtract 12 from the other side, I'll get 8x is equal to -6. So take -6 divided by 8, and that's essentially your answer. Again, you might want to reduce that. Now, checking this answer might be a little bit more complicated because it's a fraction, but you would still just do the same thing. Plug -3/4 in for x here, here, and here. Simplify both sides and see if you get the same thing on both sides. So I think that should be the slides out of order here a little bit. So I guess I'm not sure if this slide isn't supposed to be in here. Sorry about that. Let's look at an example of an example with fractions. So let's say you have an equation like this, and this is a linear equation, right? Because again, the power on the x's are both 1, and if you wanted to, you could subtract the 5/3 from both sides to get a 6 there. And there are a couple different ways you can do these problems. You can add the 5/3 to both sides, but I think later on we'll see that there's a better way of doing this, which is if you have an equation with fractions, that is, multiply both sides by the LCD. Let's say, for example, that I wanted to solve this equation. What you'd want to do is look at all the fractions, look at all the denominators, and find the largest or the smallest number that all 3 denominators will go into. So if you think about it, the smallest number that 2, 6, and 3 will go into is 6. So what you'd want to do is multiply everything on both sides of that equation by 6. So I'm going to multiply each term by that. So if I multiply this term by 6, I'll get 6 times 3 over 2. Well, that 2 goes into the 6 3 times, so I'll get 3 times 3, or 9x. If I multiply this by 6, the 6's will cancel, and I'll just get x there. And if I multiply negative 5 over 3 by 6, 3 goes into 6 twice, and so I'll get negative 5 times 2, which will give me negative 10. So this equation with the fractions in it will simplify to an equation without fractions in it. So now you can actually solve these by adding and subtracting equations if you want to, but I think typically people do not like to add and subtract equations, so multiplying both sides of the equation by the LCD is one way to get around that. If you don't mind adding and subtracting fractions, you could also solve this by just simply adding maybe these two fractions together or something like that. But the advantage of doing it this way is now the equation is a lot easier to solve. So now we're just back to a regular linear equation. You would combine like terms. So 9x's plus another x is 10x. And then simply divide both sides by 10 and you'll get negative 1. Now this isn't so important maybe in this particular section, but we will see later on that for equations with fractions you really should check your answer. So I don't know if I'll take off on it on this first exam or not on chapters 1 and 2, but try to remember to check your answer for any equation, but especially equations with fractions. And I think you'll see that this does work if you put negative 1 in for x here and x there. So these are the summary steps for solving a linear equation, right? These are basically the steps that we looked at before, but just to remind you, right? So first of all, simplify both sides by removing parentheses by using the distributive property. So distribute over parentheses and then combine like terms. And then basically use the addition property of equality to add or subtract stuff to both sides to get all the x's or variables on one side and all the terms without the variable on the other side. Simplify both sides again if needed, and then divide both sides to get the x or the variable by itself. And then if you have time, like I said, step 5 is sort of optional at this point, so you don't have to worry about that. So those are the sort of the different kinds of linear equations you might run across in this section. One other thing I want to talk about, though, is the different kinds of solutions you can have for linear equations. So I'll call this types of linear equations. So a linear equation may have 3 types of solution depending on whether it has one solution, it has one number as a solution, and that would be like the ones we just did, like this one, right? There's only one number you can stick in for x that makes both sides equal, namely negative 1. That's called a conditional equation. But you can also have a linear equation that has no solution, right? A simple example of something like that might be like x is equal to x plus 1, right? There's no way that a number can be equal to one more than itself, right? Or you might have a linear equation where you have infinitely many solutions. In other words, you can plug any number in for x like that. A simple example of something like that might be x is equal to x. Now these equations with no solution and infinitely many solutions, they won't all be as obvious as these. So we'll see that we can essentially use the process we just went through, namely this process, to solve the equation, and we'll see that something unusual happens in the case where you have no solution or infinitely many solutions. So most of the types of equations that you'll run across in this section will be conditional equations, and that's basically an equation that's true for some of the values and false for other values. So that would be an example. An example of that would be all the ones we did previously, right? There's one number you can stick in that makes both sides equal, but no other number, you can't stick other numbers in for x to make both sides equal here, right? If you make x equal to 0, both sides will not be equal. The only number you can stick in to make both sides in this equation equal is negative 1. So an equation that's false for every value of a variable is called a contradiction. So an example of that would be something like x is equal to x plus 1. So you might see in the back of the book that the equations like that would be called contradictions. I guess contradiction technically refers to the type of solution and not the actual solution itself. You might see for solutions for contradictions, you might see symbols with curly brackets with nothing in it, or maybe the symbol for the empty set, which looks like a 0. That just means that the solution has nothing in it, right? There's no solution, or if you write no solution on the exam or something like that, that would be fine. So for equations like this, if you write contradiction or the empty set or no solution or something like that, that would be fine. And then an equation that's satisfied for every choice of variable for which both sides of the equation are equal is called an identity. So an example of something like that, like we've already seen, would be x is equal to that. X is equal to itself. And so an equation like this is called an identity. Now, as far as the type of solution you would get for something like that, the solution for that would be any number. So you might see in the back of the book that they'll write, any number or any real number. Other ways you can write the answers, you might see the symbol for the real numbers. Sometimes mathematicians will use a capital R for real numbers, or you could also just use negative infinity to infinity, meaning that you can pick, x can be any number from negative infinity to infinity. So as far as equations with, so let's look at equations with one or finitely many solutions first. Like I said, we've already looked at a lot of those, but remember, those would be conditional equations. So we've already looked at those, so I don't think we'll look at any particular examples there. But like I said, this, here's an example of a conditional equation. This example would be a conditional equation, right? You can stick negative 3/4 in for x to make both sides equal, and that's the only number you can put in there. So let's concentrate on equations that don't have solutions. So like I said, not every equation has a solution. So remember, those are called contradictions. We've seen some examples, but like another example would be x plus 1 is equal to x plus 2. That would be an example of a contradiction, right? Because there's no number that can be equal to 1 more than itself and 2 more than itself. So as far as determining whether an equation is a contradiction or not, let's say that I give you an equation like this on the exam. Now, when you look at this equation immediately, it's not immediately obvious how to determine, what the solution to this is. If it has no solution or infinitely many, so you would just solve this like you would normally. You would just go through the 5-step procedure, mainly, distribute and combine like terms, and then try to get all the stuff with d on one side and all the stuff without d on the other side. So go ahead and distribute first, multiply the d through, and then combine like terms, right? So you'll have 5d here, you'll have negative 1 minus 10, which is negative 11. Here, combine the 12d minus 7d, which will give you 5d, and then try to get all this stuff with d's on one side. So what you'd want to maybe do in this case is subtract 5d from both sides, but you'll notice in this case something kind of weird happens, which didn't happen in a conditional equation, right? When we were solving, conditional equations, the variable didn't disappear. For example, like this one, right? We had an x at the end, but here you'll notice that the variable disappears, and we get negative 11 is equal to 3. And you can even boil this down even further by adding 11 to both sides or subtracting 3. So for example, if you subtract 3 from both sides, you'll get negative 14 is equal to 0, which doesn't make sense if you think about it, right? I mean, negative 14 degrees is not the same thing as 0 degrees. So if that ever happens, the variable disappears and you get different numbers on both sides, then it's a contradiction. You can basically boil this down to 0 equals a non-zero number. So again, that means that the equation is a contradiction. So if you write that on the exam, if you write the word contradiction, that would be fine. Or if you write the words no solution, or if you write the symbol for the empty set, or you write just brackets with nothing in it there, right? That means contradiction. So, and again, contradiction technically refers to the type of equation, and no solution, the empty set or this symbol means the type of solution, which means nothing, right? There's no number you can put in for d that will make both sides equal. So you'll notice for this one, right, it's maybe not immediately obvious right away that this equation is going to have no solution, unlike, x is equal to x plus 1, which is a little bit more obvious. So just be careful, right, when you're solving a linear equation, make sure you work it all the way through. And then if you do get a situation where the variables disappear and you get 0 on one side and a non-zero number on the other side, right, again, you can write down contradiction, no solution, the empty set, or squiggly brackets with nothing in it there. Now, we might also have situations where, again, equations will have infinitely many solutions, or all real numbers as solutions, and those are called identities. So here's another example. And again, it's maybe not immediately apparent that this has no solution, but has infinitely many solutions, sorry. But if you multiply the 2 through here, right, it's pretty obvious that both sides are the same. And so you should be able to stick any number in that you want for x. Now, you might run across equations where it's maybe not so obvious that there's going to be no solution, or all real numbers is a solution. So let's look at an example here. So let's say I have this equation. Now, when you look at this, at least if you don't look at the answer, I can't tell right away whether that's going to be a conditional equation. In other words, whether there's one number I can stick in for k, or whether there's going to be no solution like the last example, or whether I can stick any number in for k. So again, no matter what you do when you see an equation like this on the exam, just start solving it like you would any other linear equation, namely distribute the 7 through, multiply the 7 through, so you'll get 7k, 7 times 4 is 28, and then just combine like terms on both sides. So you'll get 7k, and then you'll get 28 minus 10 is 18. Combining the k's together, you'll get 7k here, 20 minus 2 is 18. Okay. Then get all the stuff with k on one side, all the stuff without k on the other side. And then again, you'll notice in this case, something also kind of weird happens here when I try to get all my k's alone, is the k's disappear. Now, the thing that's different here is I get the same number on both sides, and you can even boil this down further into 0 equals 0 if you subtract 18 from both sides. But if you run into a situation where the variables disappear and both sides are equal, then the equation is an identity, right? Meaning that you can stick any number in for k or x or whatever you want, right? And remember, technically identity refers to the type of equation, but I'll take that as an answer. If you just write the word identity, that'll be fine. But don't just leave it as 0 is equal to 0, because that's not the answer, right? So if you write identity, or you write all real numbers as a solution, or you write the symbol for real numbers, which is probably the most efficient way to do it, or if you want to write all the numbers from negative infinity to infinity, which means, again, all real numbers, any one of those answers will be fine for me, right? So you can either write identity, all real numbers, negative infinity to infinity, and all real numbers. My math lab might ask you to write the answer in a particular way, so make sure you pay attention to that. But on the written exams, you can write it whichever way you want to. So let's maybe go ahead and take a look at some other examples here and see if we can indicate whether these are conditional contradictions or identities. So for example, if you look at the first one here, right, you can get x by itself pretty easily by adding 5 to both sides, right, which would give you 3x is equal to 24, and then just divide both sides by 3 and you'll get x is equal to 8. So that would be a conditional equation, right, because there's only one solution, right, that depends on the condition of the equation there, right? And so if it's a conditional equation, you don't actually have to write the word conditional on the exam unless I ask you to do that. You can just write down the answer. Or for something like this, again, you would maybe subtract an x from both sides to get 4 is equal to x plus 5, and then subtract 5 from both sides, so you'll get negative 1 is equal to x. So that would also be an example of a conditional equation. This one, again, you might not even have to really do any algebra for this one just to realize that this is a contradiction. But if you do subtract x from both sides, you'll get 3 is equal to 0, which can't possibly be true. So on the exam, on a written exam or something, again, you can just write contradiction, right? But don't just leave it as that, because that's not the answer, right? Or again, you could write, if you want to write no solution, or you want to write the symbol for the empty set like that, or something like that. Hopefully by doing the problems in my math lab, you'll sort of pick what you want for that. But technically you can write it however you want on my exam. Some instructors are more picky about that than others, but whichever way you want to write it on the written exams is fine. And then so for something like this, again, again, it can be kind of hard to tell right away what sort of equation it is. So just solve it like you would normally. So let's just go ahead and maybe subtract t from both sides. So I'll get minus 6t is equal to minus 12. And then go ahead and subtract 6 from both sides. So I'll get minus 6t is equal to minus 18. So this would be a conditional equation, right? I'll just get t is equal to 3 if I divide both sides by negative 6. Just watch your plus or minus signs there. Again, this one's kind of hard to tell what's going on for this one. So you'd have 4a minus 12 minus 2a. Is that the same thing as 4a minus 4? So combining like terms here, right, you get 2a minus 12 is equal to 4a minus 4. So it looks like this is going to be a conditional equation. So go ahead and maybe subtract 2a from both sides. You'll get minus 12 is equal to 2a minus 4. And then go ahead and add 4 to both sides. You'll get negative 8 is equal to 2a. So it looks like a is equal to negative 4, right? So that would be a conditional equation. I did want to talk a little bit about solving equations with decimals. You know, if you're okay working with decimals like this, and I will let you use a calculator on certain portions of the exam. I mean, I'm not expecting you guys to be human calculators, but I may have portions of the midterm and the final or the written exams where you're not allowed to use your calculator. You know, so if you have trouble adding and subtracting decimals without a calculator, this is one way to kind of get around it. If you don't have too much problems, or if I let you use a calculator, you can, you know, you don't have to do it this way. But one thing you can do if you have trouble with decimals like this is if you have an equation like this, you can get rid of the decimals by multiplying everything by the largest decimal place here, right? And so these are all to one decimal place. You could multiply everything on both sides by 10, and that shouldn't change the value of the fraction. So multiply this by 10, this by 10, and this by 10, and that will simply move the decimal over one place. So this equation then will become 1x plus 23 is equal to 2x. And if it's easier for you to solve the equation that way, you can certainly do it that way, and then just subtract an x from both sides, and you'll get x is equal to 23 for the answer. You can plug that in and see if that works. If you don't, you know, if you're comfortable working with decimals, you don't have to do it that way, but that is one way to kind of get around those. Okay, so maybe just to summarize this chapter, you know, basically we determined whether a number is a solution to an equation, and then we looked at solving a variety of linear equations, including equations with fractions and things like that. And then we wanted to determine whether an equation, again, it basically has one solution, all real numbers, or no solution. So hopefully that should give you guys enough of an idea of what to do for that section if you're not sure. So if you have any questions or problems or anything, make sure you let me know.